Hello class, this is Mr. Hart, and in this podcast we want to continue with the motion unit by covering position time graphs and velocity time graphs. So last time we looked at how to find the distance, the displacement, the speed, the velocity, determine these values about objects. Okay, that's great for describing a straight line motion or a very simple motion. Okay, but those values don't tell us a whole lot if the object's moving back and forth a lot or changing directions quite a bit. Okay, we need a better way of describing the motion of an object. Okay, and how we do that is with position time graphs. Okay, so if we look at a position time graph, what it tells us is the different positions the object's at any given time. Okay, so for example, this graph right here, we have time on the x-axis and we have position on the y-axis. Okay, so these little increments of position tell us where this object's at any given time. Okay, so for example, we look at this object, it shows that it's going forward. Okay, it's going up on the y-axis. That means the object's moving forward. Okay, and it's moving to 60 meters. Okay, so within 10 seconds, it moved to 60 meters. Okay, then this object sat still for a second. Okay, it's not moving forward or backwards, it just sat still for a second. Then it started to move backwards. Okay, until 40 seconds time. Okay, so it moved backward to -40. Okay, and at 40 seconds it was at -40. Then it moved forward again until it was at 0. Okay, so this graph right here is showing us the entire motion of that object. Okay, it moved forward, it sat still, it moved backward, it moved forward again. So they're really nice for describing the motion of objects. Okay, and we can also find certain values as well, like the speed, the displacement, the distance, okay, the velocity. Okay, all those things are hidden inside this graph. Okay, so if we want to extract the information, all we have to do is look at certain things. Okay, so for example, if we want to find the distance that this object traveled, all we have to do is look at all the distances of the different parts of the graph. Okay, so for this line right here where it's moving up, it went from 0 to 60. Okay, so the total distance for that part of the traveling was 60 meters. Then it was sitting still for 5 seconds, so that was only 0 meters. It didn't move anywhere. Then it moved down to -40. So the distance from 60 to -40 is 100 meters. Okay, then it moved back up to 0 meters, so it went from -40 to 0, so that's a distance of 40 meters. Okay, so we know that this object traveled a total distance of 60 plus 100 plus 40, that's 200 meters. So from this graph we can tell how far this object traveled. Its distance was 200 meters. We can also find its displacement. Okay, it started at 0 meters, it ended at 0 meters, so its displacement, or its change in x, is 0 meters. Okay, so we can figure out these values just by looking at the graph. Okay, so that's what's really nice about these graphs, is there's so much information we can pull out of them. Okay, just by analyzing the different lines and things like that. Okay, let's look at another example. So let's say you have this graph right here, and we're trying to describe the motion of this graph. Okay, so go ahead, pause the video for a second and see if you could describe the motion of the graph, the distance traveled, and displacement traveled on your own. Okay. All right, so if we look at this graph, we can see that each one of these tick marks is 1 second. Okay, so this is 1 second right there. That's 3 seconds. That's 5 seconds. Okay, and we can see that it's going by 0.5 on this side right here. Okay. So if we look here, that's 0.2. Okay, 0.1, 0.2, 0.3, 0.4. Okay, so that's 0.2. So it started at 0.2 meters forward, and then it moved forward to 1 meter in 2 seconds. And then it sat still for about 2 seconds, and then it moved back to 0.5 meters for another 2 seconds. Okay. So if we're trying to find the total distance from this graph, we'd say, okay, it started at 0.2, it went to 1. So it traveled 0.8 meters in this part right here. And then it went from 1 meter back to 0.5 meters, so it traveled 0.5 meters right here. Okay, so it went up 0.8 meters, then it went back 0.5 meters. Okay, so the total distance traveled is just adding those two together. That's going to be 0.5 plus 0.8, which is 1.3 meters. If we're trying to find the displacement, okay, then all you have to do is figure out that it started at 0.2, it ended at 0.5, so the total displacement is 0.5 minus 0.2, or 0.3 meters. Okay? Awesome. So that's how we analyze these graphs. So the first part of your homework assignment is to just analyze these graphs, find those different values, when it's moving forward, when it's moving backward, what the distance and displacement are. Okay? All right, and then in class we started to use some motion detectors, which are really cool. Okay, we did a lab using motion detectors and Logger Pro, and this is a vernier motion detector that we used in class. And what they do is they use this little speaker right here, okay, on the edge of the motion detector, and that speaker sends out sound waves, okay, and those sound waves will shoot out and they'll hit an object and bounce back. And then based on how long it takes those sound waves to propagate, okay, to hit the object and can come back, okay, it determines how far away that object is. Okay, so it's really cool. It can help us find how the object's moving based on how far away it is. Okay, so in class we did that lab. It was called Match the Graph Lab. You had to match a couple of graphs, okay, based on their motion. So hopefully you have a chance to work with those motion detectors sometime. Okay, but let's move on to the next type of graph, and that is a velocity time graph. Okay, so they're a little bit different from position time graphs, because with a position time graph, it's just telling you the exact position. Okay, you can see when it's moving backwards, you can see when it's moving forwards, when it's sitting still. Okay, really easy to interpret. A velocity time graph is a little bit harder to understand what's going on, but not too bad. Let's see if we can take a look at this one. Okay, so with a velocity time graph, you have velocity on the y-axis instead of position. Okay, you still have time on the x-axis, but you're trying to see the velocity of the object over time, not its position. So the velocity time graph in this example, okay, it's a very simple example. It doesn't really have any units or anything, but you can just see what's kind of happening. It's starting at a certain speed, okay, or a certain velocity. It's moving forward really fast, and then it's not moving backwards, but it's slowing down to a stop. Okay, so it starts at a certain speed, it's moving forward, and it slows down slowly until it reaches a stop. Okay, so this is where it gets tricky, because some students think, oh, the line's going down, it must be going backwards. No, it's still moving forward this whole time. It's just slowing down. The velocity is getting smaller and smaller and smaller. Okay, so with these types of graphs, you're trying to analyze how fast it's moving, not necessarily its position at any given time. Okay, let's look at another graph. So let's say we're trying to describe the motion of this graph right here. Okay, so it's starting at 0 meters per second. Okay, it's not moving, it's sitting still. And then it moves forward and it's speeding up. Okay, the object's slowly speeding up, going faster and faster and faster until it's going 8 meters per second. Okay, and then it's not sitting still, it's moving at that speed, okay, consistently. It's consistently going 8 meters per second for this time right here. Then it slows back down to 4 meters per second, and then it continues to go forward at 4 meters per second. Okay, so keep in mind the whole time this object right here is moving forward. Okay, it's just speeding up, moving that speed, then slowing back down and moving that speed. Okay, so when is the object moving the fastest? It's when it's the highest point on this graph. Okay, it's moving 8 meters per second. That's the fastest it's ever moving. Okay, when is this object speeding up? It's when this line slopes going upwards, right? It's moving forwards. When it's slowing down is when the line slopes going down. Okay, so you can still analyze it. We can still get certain properties from it, just like the position time graph. Okay, but it's a little bit trickier to analyze. Okay, but we still can get a lot of information based on these velocity time graphs. Okay, and sometimes you'll see them broken up like this. Okay, where you see these very strong peaks right here. Okay, and some students think that the object's just moving really fast between those points, but in reality, again, this is the velocity, not the position, so it just means it's changing its speed really fast. It was moving at 2 meters per second, now it's moving at 1 meter per second. Now it's moving backwards at 2 meters per second. Now it's moving backwards at 1 meter per second. Okay, so just because there's straight lines going down on the graph doesn't mean that it's teleporting or jumping or anything like that. It's just slow. It's just changing its speed very quickly. Okay, not necessarily its position, just its speed. Okay. All right, so go ahead and try to analyze this one for just a second and see if you can figure out what the object's doing. Okay. And if you kind of work through it, you'll see that it's moving 2 meters per second forward, then it's moving 3 meters per second forward for that time duration, then it's moving 1 meter per second forward for that time duration, then it's stopped, okay, for this time, and then it's moving backwards at 4 meters per second for this time. Okay, so when is the object moving the fastest? Okay, you might be tempted to say this 3 meters per second up here because that's when it's the highest on the graph, but it's also moving fastest down here, okay, at negative 4 meters per second. This is actually when it's moving the fastest when you're looking at speed, okay, because 4 meters per second in the negative direction is faster than 3 meters per second in the positive direction. Okay, so it's actually moving the fastest right here. Okay, it's just moving backwards. Alrighty, so again, I hope you had a chance to work more with velocity time graphs. They're a little bit tricky to get used to. They're not as easy to think about as position time graphs. But on your homework, you're going to look at both. You're going to look at position time graphs and velocity time graphs. Okay. And just, again, keep in mind that you need to make sure you know when you're using a velocity time graph, when you're using a position time graph, okay, because you're going to treat them differently. Okay? But hopefully this all made sense. Let me know if you have any questions, and thank you for watching.